Today we're going to be talking about adding and subtracting radicals. When you're adding and subtracting radicals, you can think of the radical as being a variable, such as 2a plus 3a equals 5a. Okay, let's look at this one. We have 4 times the square root of 3 plus 2 times the square root of 3. Notice these are the same. If we're thinking about them in terms of variables, then these are like terms. So we can simply go 4 plus 2 equals 6, and we have the square root of 3 after it. This is our answer. It's very similar to if we say 2a plus 2a equals 4a. We cannot combine 2a plus 2b because they have unlike terms, they have unlike variables, so they're unlike terms, and this is as simplified as it gets. When we look at this problem, the square root of 45 plus the square root of 18 minus the square root of 5. These are not like terms, but we might be able to break down the radicals to make them like terms. If we look at 45, the prime factorization for 45 is the prime factorization for 45 is 3 squared times 5. And then when we look at 18, the prime factorization is 3 squared let's see, it's 3 squared times 2, and we actually have just minus the square root of 5. 5 is a prime number, so there's nothing we can do about it. This can come out. This can come out. Now we have 3 times the square root of 3. 3 times the square root of 5 plus 3 times the square root of 2 minus the square root of 5. Just like with any other variable, we can pretend like there's a 1 in front of this. And we're going to combine like terms. This is like, and this is by itself. That means our ending problem should have 2 terms because we have 2 colors. We can look at 3 minus 1 is 2 times the square root of 5 plus 3 times the square root of 2. And this is as simplified as it can get. We know that this is as simplified as it can get because both of these numbers are prime. There's no more factoring that I can do with it. And they're unlike terms, so I cannot add them. Okay, we're going to look at one that has cubed roots. If I had a problem that had both square roots and cubed roots in them, I cannot combine those because it would make them be unlike. Okay, so when we look at 5, there's nothing we can do with that. So we're just going to stick with our -8 times the cubed root of 5. 40 we might be able to do something with though. The prime factorization for 40 is 2 cubed times 5. And then the cubed root of 135, let's look at that. The prime factorization is 3 cubed times 5 again. Okay, so when we break this down, we have -8 times the cubed root of 5 plus 9 times 2 times the cubed root of 5. minus 2 times 3 times the cubed root of 5. These are all cubed roots of 5, so I can solve this down to be a one-term problem. We have negative 8 plus 18 minus 6. Negative 8 plus 18 is 10 minus 6 equals 4. So we're left with 4 times the cubed root of 5. And that is our answer.